Well, thank you. My name is Marianne Piet, and it's a pleasure to be here today. It's a great opportunity for me to speak with California's Clean Energy Economy Committee. I have some PowerPoint that I'm going to bring up on my computer here, and I want to say it's also a pleasure being the third speaker because I think this is on, right? I'm going to comment a bit on the previous speakers and link some of my comments to things that you've heard already, and you'll see some significant linkages with the material that others have presented. I'm going to talk a little about California building energy use and what it means if we're going to double energy savings. And I'm going to talk mostly about commercial, but I do have some material on residential buildings as well. And talk about future directions because I want to emphasize that the things that we're talking about today demonstrate the state of knowledge and our challenges in prioritizing where we're putting our funding. I think I do have a McKinsey curve in my PowerPoint, and I am going to talk about models and real data. And so those themes are very important to what we're trying to do here in thinking about our energy efficiency potential. I want to start by saying that buildings is the largest sector. So we use more in buildings than we do in transportation and industry. So we use about a similar amounts in residential and commercial. And if you add those up, that's almost 40%, a little bit higher than transportation. So it's a very important sector, but it's a diverse sector. So one of the comments about the Michigan study is, well, which of those measures was the most cost effective? Not just the group of them, but as you pull them apart. And it's really important that we start to understand those specific technologies. And we look not only at the energy use, but the peak demand in the state. And thinking about how to do integrated demand side management is one of our challenges in thinking about the cost effectiveness. So we forecast our load growth, and we forecast what it would have been without efficiency and what it is with efficiency. And we get efficiency from our building codes, from appliance standards, from our demand-side management programs, and naturally in the market. So it's a very complex thing to untangle. We try to untangle it, and we still have questions, as you can see from today's discussion. So as we look from 2013 out to 2024 in the CEC's load growth projection, we're saving another 10 combined cycle gas turbines. Annette mentioned earlier the savings in power plants that we had earlier. And on the bottom right, that's from the California Energy Commission in our attempt to double the savings that we're getting from the building stock. And one of the key questions is that feasible? It's much harder for me to comment on the cost effectiveness than it is on the technical feasibility. It is absolutely technically feasible, and the economics will depend on training, information, utility program design, technology costs, and transparency of information. So it's a whole set of factors that influence whether or not we're able to achieve those goals.
Could you go back to the last slide?
Yeah.
The bottom curve on the right, you've got yellow and blue. Could you explain what those are?
The yellow is the current savings forecast that the CEC has going out into the future, and the blue is the concept that we want to double the savings out to 2030.
All right, and then the yellow includes what? What are the current, the $1 billion a year that's spent by the IOUs? And
plus Title 24.
Plus Title 24, looking at new buildings.
Standards. Right.
Plus appliance standards. So that's the yellow.
Right.
And the blue is what we have to come up with.
Exactly.
Got it.
And here's the McKinsey curve, which I agree that it's a simplification, but it's the concept of the efficiency of these supply curves of efficiency is energy efficiency investments, are they more cost effective than investing in solar or investing in other deforestation and wind and other kinds of resources? And so the theory is we think they are, but it's not a simple widget. These are system issues, and these issues that Catherine was speaking about are examples of the complexities in understanding a specific strategy in the context of deploying it in the buildings. So I'm going to make a couple of comments about where some of the low-hanging fruit is in homes. California has forced air systems. We heat and cool our homes with the air from our furnace, and we know those systems leak. So the last bullet there, I'm starting at the bottom, says we need to seal the ducts to have the leakage. We will use less heating and cooling if our ducts leaked less. We will also improve our ventilation and make the homes better. So there's a lot of opportunity to bring older homes up to more common standards that we see in newer buildings using Title 24 or the International Energy Conservation Code or the home energy rating indices. So there are a set of strategies to improve the ventilation efficiency in homes. This is a list that Annette mentioned, the LED power strips. We want to improve insulation. I have a home in Oakland, a 1939 home. There's very little insulation in these older homes. I don't have air conditioning, but I do have a lot of waste from the heat that goes through those leaks, and it's very expensive to open up my walls and put that insulation in. We want to replace old appliances, and we want specifically to explore window replacements, which are very expensive, but we have to be strategic and install them at a time when somebody's going to replace the window. So we need to understand how to help finance window replacements to offset the expensive cost of windows.
What's a smart power strip?
A smart power strip is the smart plug load controller that Annette was mentioning, and essentially those are communicating. So you can program the on-off time of each of those plugs. So when you leave the office or when you work on your computer, it's going to time out, and you want your printer, your computer, and those devices to be on a controller. One more slide about homes. We really want to think about integrated packages of retrofits. We know we have to help people with the rebate programs and consider bulk purchases. So the part of the savings were not great in the Michigan study, but are there things that we can do to package the cost of the retrofits to bring them down? And that's one of the issues about scale, is how can we do statewide bulk purchases, emphasize contractor buy-in, and the last one is to streamline the process for the owners and the contractors. So we have a large vintage of older homes that could benefit from these retrofits, and as we've said earlier, designing these programs is challenging. Now, I want to make one comment about the EPIC program before I talk about commercial buildings. The California Energy Commission focuses and provides funding on research through the Electric Power Investment Charge, something called EPIC. And here's 4 examples of things that we're doing at Lawrence Berkeley National Lab that are funded by the California Energy Commission. So we're very thankful to the state for continuing to provide research funding to develop new technology. You'll see a picture there. We do a lot of work in measuring heat islands. Over many decades, we've done work on cool roofs that make the home more comfortable. You can put in a smaller air conditioner. We're now working on a project on cool walls. So we're actually trying to help in many hot climates to actually make the building more reflective. The picture there of the active airflow window is to help harness the heat when you want it and reject it when you don't. So it's a two-way window ventilation system. And then DC-powered buildings. We're looking at DC power as opposed to AC power that would better use renewables and solar systems so you don't have inverter losses, and link many loads that are DC loads to a DC-powered system, and there may be significant opportunities there.
So here you're talking about somebody who has a solar system.
Yeah.
It's delivering DC, then the DC is converted to AC to go on the grid, and then the AC that comes in from the grid is changed into DC for computers and other systems.
Exactly.
So you're saying to the extent that you could use your solar power directly,
That's correct.
DC to DC. Okay.
That's right. I'd like to comment a little about commercial buildings. The biggest theme in commercial buildings is moving from widgets to systems. So this concept about computer codes is important as we try to design packages of retrofits. We want to understand what the shades are doing, what the lighting's doing, what the HVAC is doing, and have a coordinated system that's controlled as a system. We have a lot of opportunity to reduce the heating and lighting, the solar gain that happens through the windows, put on cool roofs and cool surfaces, put in more efficient HVAC. That concept up on the right, the bullet that says continuous analytics-based operations and maintenance, that's a huge opportunity where we're starting to collect the data and use it as part of the control system. Today, you pay the bill once a month and you run the building. And in the future, you need real-time data to make sure, were the fans turned off last night? Is the economizer working? Is the chiller doing the right thing at the right time? So we're moving towards this concept of retrofitting the pieces to retrofitting it as a system and managing it as a system. So we want to have aggressive approaches that combine the operational and the capital measures. And this slide is further material on that concept. This concept of energy management and information systems is one that Annette Beitel brought up with the first fuel example with GSA. So we're moving towards a time, and the picture on the right shows you before and after data from a retrofit. We're moving towards a time where we want to have the ability to make sure that the measures perform as intended and that the savings persist. So we want to start taking data and using it in the commercial building operations to make sure that the energy use of the building is retrofitted and kept low and stays low. The concept of retro-commissioning, Annette brought up as well, as a very good way to tune up a building and to save energy by making sure that the control system's working like it should. We tune up our cars, but we do not tune up our buildings. So we have to have a much more aggressive activity to use energy management information systems, identify the capital-intensive retrofits, monitor the efficiency savings over time, and make sure the savings are persistent. This slide gets back to the concept of a model. We believe in the commercial sector, it's time to think about guaranteeing the performance of an efficiency measure. A lot of the discussion this morning has focused on the problem associated with the savings not being realized. We'd like to make sure that we have better analysis of the uncertainty and the financial systems that are used to fund a retrofit, take advantage and acknowledge the risk, and that there are legal and contractual frameworks around that risk. So this concept of ESCOs and energy service performance contracts have historically been for schools and hospitals and municipal buildings. And we'd like to make these kinds of tools more available for the commercial sector and make more investments in building performance and ensure the savings persist so we have some feedback on what we thought the retrofit savings would be and what actually performs. We have a new facility at the lab. I want to share a few words about it with you. And this is called Flex Lab. It's a set of side-by-side test beds. On the right there is the very middle one is a rotating test bed that we use to test how the sun angle changes on the facade. And that particular windows there are from Genentech's building, where we were modeling some zones of the building and testing the lighting controls and the facade elements before the building was actually built. So as we try to do these integrated designs, we want to see how the lights, the HVAC, and the facade systems work as a system. And I'm happy to say this is an important piece of what we're doing to calibrate the models. So we actually run tests in these buildings and try to make sure that the models that we're using for those integrated system retrofits are calibrated based on real test cell data. So we want to be able to reduce the risk of bringing new technology to the market. That's the goal of this research. Improve the depth of savings, accelerate the speed of bringing it to the market, and scale the adoption. We are spending a lot of money in the state of California on autonomous vehicles. We are making great strides in our technology infrastructure. We need to make similar kinds of investments in the buildings. We need device integration. We need the middleware and the applications. And so it's important as a state that we acknowledge the opportunity and engage Silicon Valley in the investment in the opportunity. We're having trouble doing automated blinds, but we can do automated vehicles. So it's a little bit ironic. This is my second to last slide. Many of you are familiar with the duck curve. And the duck curve is about the problem that we have in California in the spring when there's a lot of solar on the grid. And in the afternoon, we have a steep ramp. So the duck we need to try to flatten. And one of the ways we do that is the buildings are a big part of the load. They dominate the load for the demand side systems. and we want to reduce the total load as well as flatten it. And going back to the concept in the previous slide, this is a layered system about interoperable building controls with an application layer to devices on the bottom, a middle layer for control and scheduling, and a top layer that would allow a building operator to understand what's happening to his lights, his PV systems, his HVAC systems, and can he understand whether the energy use is optimized, whether there's opportunities to change the electric load shape in receiving grid signals, whether there are asset and financial management tools that they need to develop. So this is the concept of an internet building operating system that we're working on with industry to try to improve the visibility of the performance of the end-use systems. And this is my last slide. I really appreciate California's historic leadership, and it would be great to continue our leadership to build partnerships between research and practice and to make sure that we continue to provide the next generation of research and energy efficiency activities here in California. The whole building pay for performance theme is an important one. I think we'll probably talk about it a little more this afternoon. We want to use state buildings for living lab research. We want to get that data out into the public domain to educate the industry on what's possible. California is in a very unique position with Silicon Valley to do dramatic things with the Internet of Things in buildings, and we have a strong foundation of universities, national labs, and industry to help create an important pipeline of technology.
Great. With regard to that last slide, let me know how I can help developing that lab here in the state buildings. Let's have a discussion on that. I'll also comment, I'm not going to want to think about when solar energy is high during the day, so I should be pre-cooling my house so I don't have as much demand at night, etc. So the idea of automating the building so I don't have to think about it, I don't see any other way of adjusting these things that would be reliable. So I think that's another great idea that you brought forward here, aside from the technical things like ductwork, et cetera. Assemblymember O'Bernalty.
So I was intrigued when you talked about using DC to DC power delivery to reduce the losses in inversion. But that only works to the extent that you've got a high amperage use for DC energy. And most of the uses that I'm familiar with, I mean, certainly computers and televisions now, it's a low amperage use, not a high amperage use. So how would that be worthwhile?
Yeah, I mean, there certainly are motors and other sorts of loads. So you're right. We're actually doing the study to look at which loads in the home are viable for those kinds of DC systems. So you raise a good point that we're looking at the viability. It's a current project.
Because most motors are going to be more efficiently done with AC than DC. I mean, certainly compressors and air conditioners or anything that I can think of in a household setting.
Yeah.
All right.
Yeah.
Assemblymember Williams.
Well, because you brought up the demand response device question and potential, a lot of the things that we deal with in energy usage seem to guide us to be pretty pessimistic about how much initiative individual consumers will take. And yet the model at this point of demand response devices entirely depends on individual consumers taking initiative, right? So it's like it's hard for us to think if people won't spend more than a few minutes a year thinking about how much their bills are, will they really go out and buy a $100 device or a $150 device to manage it for them? And it leads me to wonder if there wouldn't be better models, i.e. that we use ratepayer funds to just buy them for everybody and install them everywhere, except people who want to opt out for whatever reason, who essentially, from your perspective as a expert in this field, who should buy them?
Sure.
and how should we promulgate them, because the model that we have is just not working.
Right. Well, you may be aware that most of the programmable communicating thermostats, like a Nest or an Ecobee or a Honeywell thermostat, can now receive automated demand response signals. So those systems, it was pretty easy to get signals to them. So if a consumer buys a Nest thermostat, they can hook up to their utilities demand response program very easily. So that's one comment. Then the other comment is for large commercial buildings, using the building codes as well as the alliances for automated demand response. All the big control companies, Honeywell, Johnson, Siemens, are building that into the controls. So it's going to be easier to hook up things than it has been in the last decade.
Yeah, I mean, I can see commercial entities taking advantage of this.
Right.
And I see every reason why residential customers should take advantage of it.
Right.
But, you know, not just after looking at Catherine's study, but every other one that seems to deal with individual initiative on a residential level seems to lead us that we should be pretty jaundiced in our optimism of how much they will do unprompted.
Right. Well, there is a lot of education needed to the consumer, and thermostats do change over, regularly. They're probably installed for 10 or 15 years. Some people, as you say, are buying the fancy stuff, but certainly not everybody. So looking at bulk purchase opportunities and making some sort of thermostat controllers available to a broader part of the residential market is definitely true. So as we talk about residential, small commercial, or large commercial, they are very different decision-making and adoption patterns, and acknowledging that is important. Yeah.
And any thoughts about who would be the most efficient entity to nudge to buy and promulgate them?
Well, the utilities certainly have the historic relationship with the customer. The utilities are also definitely looking at new partnerships with the aggregators. And there is a demand response auction mechanism pilot going on now that the electric utilities are partnering with aggregators in new ways. So those models are evolving quickly.
Okay. Thank you.
Okay, Dr. So next we have Dr. Professor Michael Simonovich.
Assemblyman Quirk, Committee, thank you very much for inviting me here today. It's a real honor to talk to leadership in this arena. My name is Michael Simonovich. I'm also the Rosenfeld Chair for Energy Efficiency at UC Davis, also a professor, and I run the Lighting Technology Center. The Lighting Technology Center was set up as a private-public partnership at UC Davis between the Energy Commission and the manufacturers of lighting technologies and lighting components as with the purpose of creating a pipeline of delivering new energy-efficient technologies, design, and practice to the marketplace. I'm also President Napolitano's graduate student on her carbon initiative, which is a very bold proposal on carbon neutrality. I was the co-author for the strategic lighting plan, which set in motion some really deep and visionary types of objectives for deep energy savings. I was the lead on the adaptive lighting initiative, which is putting 50% savings opportunities in place via Title 24 for exterior lighting. As of 2013, adaptive lighting is now a requirement inside parking garages and exterior lighting connected with the building, routinely delivering.
Adaptive lighting is?
Meaning the lighting will respond according to occupancy or presence. And it's a very robust, very simple approach to generating very large energy savings. UC Davis and UC Irvine have completely relit their entire campus community, generating more than 70% energy savings. So there's enormous opportunities to be had. I'm here today to encourage a vector forward to deep energy savings. It's more than possible to save 50% energy in our buildings. And I'm using this particular building as a metaphor for this. This is an architecturally award-winning building, and I use it every year in my final exam of all the kinds of things you should not be doing in buildings. This is using all efficient technology, et cetera, but unfortunately there's nobody home, and this is on a Sunday evening. So there's nobody there. Efficiency is only one part of the equation. It's the time function. And so we're actually interested in energy savings as well as efficiency. So I think the main points that I would like to bring to the committee are, to achieve energy savings, we need to focus on four big things. One is encouraging best practices at multiple levels, and this is the design community, the architectural community, the engineering community. We need to engage in education, education across the spectrum of opportunities, all the way from contractors to designers. Attribution, where we reward people to engage in energy efficiency, I think needs a lot of attention. And we've already seen some discussions on this now where we don't really understand what the energy saving potentials are, and we don't reward people. Coherent policy, this is really a key effort where the right hand needs to know what the left hand is doing in terms of encouraging it. Last on my list is technology. I think we have to have a technology focus, and very key to achieving these goals. I want to get into each one of these points. If a Californian walks into a retail outlet for lighting, this is the kind of scene that they see. And you'll be hard-pressed to find anything energy efficient in this marketplace. Okay? We're basically dominated by using incandescent light sources, and the kinds of technologies that are made aware to homeowners are not there. And so the choices really limit our opportunity for deep savings. Sadly, in the state of California, which has spent so much money on energy efficiency, 75% of the energy used for lighting is still from low-efficacy lamps. That means incandescent. So there's a 50% savings opportunity straight out by engaging in this marketplace. What this means is a rapid market transformation to LED lighting. LED lighting is going to get us there. It's going to address a lot of our goals. But we need to be much more mindful of customer experience, and that so consumers get the kinds of things that when they buy light sources, they're buying service. They're not buying energy efficiency. And if you look like a ghost when you turn the lights on, people are not going to be happy, and we're not going to get our long-term transformation. And so I think California is a leader in this arena. There's three areas for residential: education, policy, and attribution. We do a very poor job of educating the consumer. This is just an abstract of lighting facts. The information on this is incomplete and technically wrong. That's a very bad combination. We're telling customers the wrong things, and we're not really engaging them in the true issue on lighting. Policy, we need to be more aggressive in terms of getting this technology mandated and encouraged. Attribution, we need to reward the utilities more on actual energy savings than relative to some consultants' estimate of what the energy savings are now. And for an example, when we rebate LED technology, the attribution in terms of the rebate dollars is not based on going from incandescent to LED. And this is a mistake. And it doesn't really matter whether we're doing a $1 rebate or a $5 rebate. It's immaterial. We can transform the California marketplace today, and we should energize that.
Could you say what's wrong with this label?
So if you start at the very top, brightness, and it says 950 lumens. Lumens is a measure of flux. It's like gowns. It's the total amount of light coming off that. It's not brightness. Brightness is the unit light per solid angle called luminance, and brightness is depreciated. If you go down to light appearance, it says 2700 Kelvin, which is an indicator of the warmness or coolness. Light appearance also has to do, more importantly, with color rendering, not coolness or warmness. So you're depriving the consumer of the most important piece of information. The bottom says energy used. It says 13 watts. That's power, not energy. And so when I've gone back to the folks who've made up these kinds of things, they say, well, Americans are not ready for the truth. And the issue here is that unless we start educating consumers about this and not dumbing down this kind of information, the better. A person cannot make an appropriate selection based on this information. Commercial buildings. We do an excellent job architecturally of bringing daylight inside buildings. And it's already been pointed out that buildings are your big energy user. And there's a 50% savings potential here with daylighting. If you want to save energy aggressively today in commercial buildings, you go after daylighting. Sadly, less than 5% of the buildings use what's called daylight harvesting. And daylight harvesting means you take advantage of the architectural details and you dim or switch off the electric lighting in response to daylight. This particular picture is of one of the largest computer companies in the world, and they have more than enough money and technology to be able to switch off or dim those lamps. Okay? This is your largest opportunity, and it's available today. Okay? This kind of scene is seen anywhere. You don't have to look very far. Every commercial building has these kinds of scenes. It's a typical corridor where we're well lit, both daylighting and electric lighting. And so this is a very simple, large savings. It's 50% opportunity for California. Why doesn't this happen? Again, it goes back to my 4 points. One is we have not clearly articulated what are the best practices for daylighting. Daylighting is a system approach and it requires multiple integration of technology. Education. We don't teach building designers, architects, contractors on how to do this. Coherent policy. We talk about daylighting in our current standards, but it's not been aggressive. And actually, in the last round of Title 24 for renovations for existing buildings, the daylighting measure was removed. And that's because there's simply not a strong systems lobby supporting daylighting. Attribution. The consultants who bring together what are the savings information on daylighting to the utilities so the utilities can energize this don't have great estimates on what the savings are. More on commercial buildings. Corridors are one of the largest opportunities inside buildings to save energy. Corridors are very well lit, typically on 24/7 and unoccupied. We did a large study down at Santa Barbara. There are people inside corridors less than 30% of the time, meaning very simply that there's a 70% opportunity to save energy today in one of the largest opportunities for reducing lighting load. Understanding where lighting is being used is a critical opportunity for California. We can't target our dollars unless we really know what's the low-hanging fruit. And certainly corridors is one of the big ones. There is technology today that you can put into a corridor to save 50%. We've put this into the new Title 24 standard that requires this in new buildings. And again, sadly, this was greatly reduced for renovations, which is a mistake. We need to be better about articulating best practices. We need to reward people to do this. We need to educate the building owners and operators that this is good, and certainly coherent policy. The policies need to line up. We're not going to get this low-hanging fruit unless we do so. Everything you see in this picture is an opportunity. Okay? None of this is useful. This is all high efficiency. This is all LED and HPS, some of the most efficient technology on the planet. Yet we still have 50% opportunities here because this is an egregious level of waste. Again, the point I'm trying to make here, it's not only efficiency, it's about time of use and lighting controls. This is the most efficient lighting system that you could make, yet it's 50% wasteful. Okay? And it's basically roadway and parking lot lighting systems. You don't have to go very far to see scenes like this. Any flight into Sacramento will drive you over acres of parking lots that are illuminated at 2 o'clock in the morning. You do not need to do this. This is a savings opportunity today. And it can be done with technology that's available. This is a street lighting system with onboard controls and a networked lighting system. This will give us 50 to 70% savings. We've deployed this at UC Davis and at UC Irvine, and the idea that this street will navigate down, modulate down to a lower light level when there's no one there during periods of inactivity. We can get 68% savings. We've measured this. We've given this to the CPUC. We've told the consultants that you can get huge savings on this, and this is not attributed. And there's statewide studies done by many universities that this savings is robust. Yet we're not rewarding anybody to do this. This is the UC Davis campus. Every one of these red points is a smart, bi-level adaptive lighting point. Technologies here. We are getting 70% savings today with this. You could do this in every single city, municipality, college campus, school, hospital in the state of California. And we can do this now. Okay. We need to engage more forcefully in education and training. I created the California Lighting Controls Training Program for electrical contractors, and parts of that material now is in our new standard. We don't engage well in education and training. And so, to finish this up, the food chain here in terms of education, we're very good at visioning goals and looking at large energy savings. We then design buildings, we build, we install equipment, we complete the building. But we're very short on education on best practices. It's hard to find somebody to pay for that. It's hard for somebody to really understand the long-term value. What you want to do is educate people who are putting together buildings and doing large retrofits. We're missing enormous opportunity by focusing on payback as opposed to cost effectiveness. It doesn't matter so much what the first cost of these things are if we're going to be losing huge amounts of energy savings. And I see this time and time again with people making short-term decisions, making short-term purchases, and leaving a lot of energy on the table. We need to get in front of this if we really want deep energy savings. So I'm going to leave you with the thoughts that there's essentially 5 things. We really need to articulate more clearly best practices. We need to educate the heck out of this food chain, all the way from architect through to the folks that are running up and down ladders. Attribution. We need to reward energy efficiency. Use the engines that we've got here. The utilities are a powerful engine, and let's get out and rebate the heck out of these things so that we don't have incandescent light sources. Coherent policy. Left hand needs to know what the right hand is doing. And, of course, technology. We need to continually invest in new technology. So that's my presentation.
That was fantastic. Dr. Simonovich, we have to sit down and figure this out.
Yes.
Some of this may be legislation, some of it may be educating the regulators, but you've made a very great case.